So there was one or two kind of topics, concepts that I left out from Friday that we need to cover today. So on your quiz tomorrow, we're going to do everything that we did Friday's homework, okay? Finding the y-intercept, finding the axis of symmetry, the equation for the axis of symmetry, finding the vertex, coming up with some points. That's all going to be on your quiz. And then what we're going to cover here today is also going to be on your quiz. Okay? Now, this is on page 534 in your book if you want to screenshot it. If you want to take a picture of the screen, you can do that as well. But go ahead and get that situated in your notes, and then I'll talk through it all so we can figure out what's going on here. So there's a couple things going on this page that I need to draw your attention to. One of the things you found out while you were doing the graphs from Friday is that it is possible for a parabola to open down. Okay, that's going to happen specifically when A is negative. So over here on the right, when A is negative, the parabola will open down. When A is positive, as all the other problems were, the parabola will open up. Now, here's the things that you need to keep in mind with respect to that. When a parabola opens up, the vertex will contain the minimum value. And so the y-coordinate of the vertex is going to be the minimum value for that quadratic. So when we're working on our homework today, you are still going to have to find the vertex. And then you pick the y-coordinate off, and that also serves as your minimum value, because if you notice here, there are no values smaller than that vertex. Okay? Everything from that y on up is going to be part of the graph, and we're going to talk about domain and range here in a minute. Okay? When A is negative, we have a point that it's at its sort of at its peak, and everything below that is smaller than it. So what I end up with is having a maximum value there, and again, the y-coordinate of the vertex is going to be the maximum value. So you can think about it in a couple different ways. If the parabola opens up, the vertex is the bottom or lowest point. When the parabola opens down, the vertex is the highest or maximum value for that function. And that's really what the rest of this section is all about, identifying the maximum and minimum. And you can do that without graphing, because if you know which direction it opens because of the A, then you know whether or not there's a minimum or maximum. In either case, you still have to find the vertex, okay? Because the y value is the minimum or maximum. It's all about that y value. That y value is the minimum or maximum. And you just have to decide, based off of what A is, whether there will be a minimum or maximum, okay? Now, we've found domain and range from graphs before. And we're going to do that again specifically for these types of quadratics. So that's for a second. And Ryan just mentioned it. Is this kind of like the boundaries that we talked about before? And it's exactly like the boundaries. So, for example, on the graph that opens up, we have a bottom boundary. So the range is going to be at that y value or greater than that y value when A is positive, meaning it opens up. When A is negative and it opens down, we have that maximum value, so it can be that top y value or everything below it. Now, that concept that we used before, you can still draw the graph and find the range from it, but for your homework today, you don't have to do it with the graph. The understanding is that if it opens up, there's a minimum, and the y value is from that minimum on up forever. If A is negative and it opens down, then it's that y value is its highest and then less than that.